All right, let's talk about our mutation lab. This is a paper lab, and brought to you by Curious Maryland. All right, so what I'm going to do is show you the paper copy. This is the student copy, and I'm going to walk through this. Now, I've copied some of this into PowerPoint, so it's easier to write on. So let's do this. We're going to look at what we have to do here. First, we have our segment of DNA. And so we're going to do what we normally do. Transcribe it, and then translate it. All right? So we're going over the directions. So what do you need? You will need, here's the first one. Here's your original DNA strand. Transcribe, translate, which means you're going to need a codon chart. So here's our codon chart. Remember, first base, second base, third base. If anything, this gives you good practice for transcription and translation. So let's look at the first mutation. First mutation, scroll down here. If you read through here, you're going to find the sixth spot right here, and you're going to write an A. Everything else is going to be the same. So I'm going to write that in. Right there. So that's the only mutation. The rest of this is the same. The rest of this should be the same. Then you're going to transcribe it, and then translate it, and you'll get transcribe and translate, and you'll get an amino acid. So that's that one. Mutation 2 requires you to think about this, and this is going to cause something to happen. Okay? Let's look at this. First, you're going to notice, here's your original DNA. Here's your mutated DNA. You got these 15 codons. 15 nucleotides. 1, 2, 3, 4, 5. Or I should say 1, 2, 3, 4, 5 codons that will determine the amino acid. So what are you doing here? Number 2 gets deleted. Number 2 gets deleted. So that means the T is going to move up. Number 3 moves into position 2. Number 4 moves into position 3. Oops, there we go. So pretty much everything is shifted up. This is referred to as a frame shift. So that's a frame shift, and all these letters move up. You'll see the results better when I go over them. All right. Okay, we have one more mutation to do, and that is number 3. Now, this, as it says, suppose a T is inserted. This is a addition. So we're sticking the T right here. Okay, let me go write that in. So your first A is going to be the same. You're going to have a G, but then we're sticking in a T. At first it looks like it's the same, but what this does by sticking a T in there, you notice this is a frame shift going down. This is going to shift all of these going down. All right, so what I want you to do, if you're one of my students, go ahead and do the video, pause the video right now, and then we'll talk about results. And so yeah, this is also going to be on Blackboard, so I'm going to go ahead and pause it, and I'm going to come back in a second. Are you ready to talk about results? Okay, here we go. So first one, before we do each one of these, let's remind you of what's going on here. This last one is not going to show up. But here, substitution, deletion, insertion. The first one was a substitution. Did it have any effect? So let's talk about that. No, it didn't. Serine to serine, tyrosine, asparagine, isoleucine. So this one base didn't have any change. This mutation, this point mutation, did not have any change. Look at your codon chart. See this? Let's look at valine, for example. They all are GU, but they could be any of the 4 or other bases. So a change in the third base of a codon sometimes produces the same amino acid. Now, if I let's get rid of this. If I actually, let's bring me back. Now, that was G, U, and then any of these. But if I change the second base, if it was supposed to be GU and something else, and it turns into GG, you've now gone over here. That's a mutation that turns valine into glycine. What's the impact of that? Well, it depends. Is it a polar amino acid, a non-polar, charged, soluble? Those are things that would affect its functionality. And I'm going to do another video where I do some practice with that. All right, so let's look at the next one. Mutation 2. So here's your mutated DNA. I'm sorry, here's your original. This is the original. Apologies. Here's the original. Now look, something happened. There's this frame shift. See all the letters? If you look here, compare, there's the T. The T is in the second spot. It was in the third spot over here. Consequently, it gets transcribed from UAU. It was UCA. So we have a change here. We have a change here. This one deletion changes all of them because it frame shifts. It shifts all of the letters up. That's a frame shift in the up direction. And now, of course, this is, I shouldn't say up. I should just say it shifts it towards the original, the first base. It shifts it towards the first base. The next one, mutation 3, now watch what happens. We inserted, so it's AGT, now it's AGTT. It's supposed to be AGTA, now we have two T's. So here we've inserted another one. Actually, it was done here. And what does this do? This is a frame shift away from the first base. And look what it has done. First amino acid the same, different, 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 and different. And now you got a floating nucleotide out here, right here. So that's pretty much these three mutations, and that's a good way. So as we can see, one mutation can cause no change or cause a change in the amino acids. If you change the amino acids drastically, you change their function. You change their function, or you change their shape. If you change their amino acids, you could change their shape. If you change the shape, you could lose the function. Brought to you by Curious Marineland.